Pythagorean theorem is one of the most famous and most commonly used proofs. So let's increase our mastery of mathematics by understanding how we got this theorem. Let's say we have a triangle with hypotenuse C and legs of A and B. And there's also a right triangle as denoted by the 90-degree bend right over here. So what if we duplicated that triangle and we made sure that this forms a straight line. So A and B, these side lengths that I circled in red, form a straight line. What if we do that again and we make sure that this A and B, this side, is also a straight line? And we do that a final time to make sure that A and B here, as well as A and B here, are also in a straight line. Well, if we do that, then, well, it turns out we're just going to get a giant square because all of these side lengths are just going to be A plus B. All of these side lengths are A plus B, which means that all of them are congruent. And if you have a shape with 4 congruent sides as well as 4 90-degree bends or 90-degree angles, well, that means that you have a square. So this giant square, or this giant shape, is a square. What about this white shape in the middle? How can we definitively prove that this is a square? It looks like a square, but how do we know? So let's first start off by making some angles. So let's call this angle right over here angle alpha, and this angle over here angle beta. So we know that, well, looking at this triangle here, we know that the degree, or that all the angles in a triangle must add up to 180 degrees. So, and looking at this triangle, we see that alpha plus beta plus 90 degrees is going to be equal to 180 degrees. And we can subtract 90 degrees from both sides to get that alpha plus beta is going to be equal to 90 degrees. Well, knowing that, because we said earlier on that this side length is in a straight line, as well as every other things, all the other side lengths, they're all straight lines. Well, the the degree measure of a line is also going to be equal to 180 degrees. So let me redraw the angles. Have an angle alpha, and then you have an angle beta. Well, since all 4 triangles have the same side lengths, they're pretty much all the same triangle. So that means that the angles are the same as well. So this angle over here is also beta. And we know that alpha plus beta is going to be equal to 90 degrees, as well as this line right over here. This line, let me extend this so that's a bit more clear. This line over here, well, because we constructed everything as a line, we know that this is a line. And this line over here is going to be equal to 180 degrees. So angle alpha plus beta plus this angle in green, so let me do that in a different color, in white, must equal to 180 degrees. But we know that alpha and beta is already 90 degrees. So it follows that this angle right over here has to be 90 degrees. Let me just erase some of this stuff. So if it's 90 degrees, then we know that, and we can use this reasoning for all the other angles. We find that the white shape in the middle is also a square because each one of these side lengths has a measure of c. Alright, so now we can get on with the proof. So the area of this giant square, because it's each one of its side lengths is a plus b. So the area of giant square, area of square, is going to be equal to a plus b squared. Let me erase some of this stuff so that we have a bit more space. A plus b squared. And we can also find the area using another way, but this time utilizing the white square in the middle. So we know that the white shape is a square, and because it has a length c, area of white square is going to be equal to c squared. But that's only the area of the white square. What about all the triangles surrounding it? Well, if you recall, the area of a triangle is going to be equal to 1/2 base times height. And in this case, B is the base and A is the height. So this is also equal to 1/2 AB for our triangles here. And the area of a triangle, just a quick reminder, is derived from the area of a rectangle. So let's say the rectangle has a side length of A and a side length of B. Well, the rectangle will have an area of A times B, and since a triangle is just half of a rectangle, that means it follows that the area of a right triangle at least is equals to 1/2 A times B, or 1/2 base times height. So we have the area of one triangle. Oh, there's 4 triangles in this picture. So that means that the total area for the triangles is going to be equal to 4 times 1/2 AB, which is going to be equal to 2AB, because half of 4 is 2. So the area of this big square can also be expressed in terms of c squared as well as the triangles. So it's also going to be equal to c squared plus 2ab. So, well, why does this matter? Because as it turns out, we can expand this. We can expand a plus b squared, which is the area of the square, into a squared plus 2ab plus b squared. And we did this because we can just FOIL this out. So a plus b multiplied by a times b, or a plus b. A times a is a squared, a times b is ab, b times a is ab, and b times b is b squared. So we're going to end up with a squared plus 2ab plus b squared. So the area of the big square is also going to be equal to a squared plus 2ab plus b squared. But look, it's also equal to c squared plus 2ab. So area, I'm just going to represent it, area as with a big A. Area is equal to both of these. So which means that these two are also both equivalent. So c squared plus 2ab is going to be equal to a squared plus b squared plus 2ab. Well, notice how there's a 2ab on both sides, so we can just subtract that. We can subtract 2ab from both sides, and we get that c squared equals to a squared plus b squared. So this was just a simple proof on the Pythagorean theorem. If you like this proof, or if this video has given you value, then please consider supporting the channel. If you like this concise and OBS way of teaching, then also please consider supporting the channel. Regardless, thank you for your time and attention, and good luck with your studies.